welcome back. Today we're going to sink our teeth into a fun real-life problem, and actually one of the problems that one of the creators of linear programming, George Dantzig, actually gives credit to getting him thinking about how to solve a linear programming problem. So pretty important problem, actually, and kind of fun. So we're talking about the diet problem. All right. So let's take a few minutes and go through, before I spend a little time showing you how to solve it actually using some different software tools. For example, Excel. We'll solve it in Excel. Let's talk about the diet problem. So you can probably imagine when I say the diet problem what it might mean, but it basically means you have a list of food that you can buy, and each food costs a certain amount per serving, okay? And some will be more expensive, some will be cheaper. And each item, each serving of food has a certain amount of nutrients, all right? Maybe it might have no vitamin A in some foods and then a lot of vitamin A in another food. And what we want to do is we really just want to find the cheapest combination of foods that will meet our needs to be a healthy meal. So, for example, the FDA might have a list, and we'll share some of this data, a list of minimum and maximum amount of, let's say, vitamin A that you might need per day. Okay, so we'll try to meet those constraints and find the cheapest combination. All right, and actually, it turns out the solution comes out to be kind of funny, and we'll take a look at that in another lecture. All right, so let's take a look at this. Let's talk about the variables, and I sort of mentioned it here just real quick, the constraints and our objective. All right, and then we're going to formulate it as an LP, and in this specific lecture, I'm just going to use the inequality form that we discussed already. All right, so let's see. So what are the variables? Well, as I had mentioned, the variables are, well, you have a list of food, and really your variables are how many servings of that food. Okay, so for example, you have you have a finite list, so there are only n variables or a list of n foods you can choose from. And so for example, X18 might be servings of carrots. All right, so that would be X18. Okay, and here let me show you. I'll share this list with you. But if we look here, you can see a whole list of foods. Okay, so let's go to carrots. All right, so there's one of n lists. I think we have about 64 foods to choose from in this data set. Okay, so let's just focus on carrots. Well, you see carrots per serving have a certain amount of calories. They have no cholesterol, certain amount of fat. Here we have vitamin A, certain amount of vitamin A, and of course it has a specific units which is given. And then, of course, you have calcium and you have some iron. And then a very important list here is the amount per serving. All right, so we're going to talk about that. And also, if I scroll a little bit more, here's the FDA data telling us, for example, here we have vitamin A. What's the minimum we should have per day, and what is the maximum if there are? And it looks like all of them have suggested maximum. All right, so let's go back to the list, and we'll come back here and we'll focus on carrots again. If we go back to this conversation, well, let's say we chose carrots, but we need to know how many of each, what is the amount of nutrient per serving of carrots. All right, so here we have a number of nutrients, specifically M nutrients versus N foods. So vitamin A. Okay, that might be nutrient. Well, let's just take a look real quick as we're talking. nutrient A is going to be, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be nutrient 8, okay? So nutrient 8, so I equal to 8 is vitamin A, okay? And we have a lower bound, so as we saw on that list, I think L8 was equal to 5,000, and U8, the upper bound on the amount of vitamin A that you want, was 50,000, I think I read, okay? So that's great, but here we're talking about carrots. I want to know what's the amount of vitamin A is in carrots, all right? So that's given in a list, as you saw, that big table, and I'm going to say that nutrient 8 for food 18, so A8, 18, in that matrix was equal to, and we'll look, actually I'll just define it, I don't need to give you the number's in there, is the amount of vitamin A in carrots, in a serving, I'll be specific, in a serving of carrots, raw carrots, as if you read it, okay? So this is what we're going to try to do. We're going to try to meet. Now, we might need to eat way too many carrots to meet our vitamin A, or maybe not. But we want to have a mix of foods. We're going to try to find the best mix, of course, but that we meet all our nutrient constraints, but of course we want it to be the cheapest. All right, so again, I showed you that column of costs, but we need to know how much one serving of carrots costs. So C18 is the cost per serving of carrots. All right? So now, let's go ahead and let's formulate it. All right? It's hopefully now we understand what our problem is. All right? So we're going to put it into inequality form, as we had talked about. And our objective is easy, all right? Let's say we buy a little bit. We don't actually know how many servings of carrots, but I'm going to leave it as a variable. And I'm going to say the total cost is equal to, well, C1 times the amount of, which is the cost per serving of food 1, times the amount of food 1 we bought, so on and so forth, all the way up to Cn times Xn, and that's going to be my total cost. And what we want to do is we want to minimize that. So this is simply minimize C1, C2, a vector of C's, transpose times your vector of X's, X1 dot 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 Xn, and this will give you, this is X, and this is C transpose. Okay, so that's it. We're actually, the cost was very simple, and didn't take us too long to put that together. All right, so that's our objective: minimize the total cost. Now we might have zero. If we have 0 servings, it'll take care of it and won't include it in the cost. All right. Now, another important, we didn't actually talk about that because this is not in one of the standard forms. This is an inequality form. We have to tell the computer or tell the problem that these variables need to be positive. Okay, so amount of servings of carrots, X18, cannot be less than 0. Okay, so it's non-negative, and we have to tell, so cannot be, all right, less than 0. So we have to tell the computer that. So let's put it into, now of course I could list them. I could say X1 has to be greater than 0, X2 has to be greater than 0, dot, dot, dot. Or I could put it into a matrix form, okay, and say, and you'll have an identity times your X vector, and then that has to be greater than or equal to, so non-negative, and then a 0 vector. Okay. Also a simple constraint. Now I'll rewrite that. Now, as you can see, we like to put things in this inequality form. We like to put it into the less than. So if I multiply by a negative, we'll find that this flips. So what I get is, my final version is minus I, and this is going to be an n by n matrix. So I could write n by n here. So it's identity times your vector x is less than a 0 vector, okay, which is n by 1 vector. Okay, so I'm going to hold on to that and finally define the final constraint. All right, so the final constraint is the nutrients. So remember, we want the amount of nutrients per the foods that you bought. So here, let's talk about that. Let's find out the amount of nutrients of nutrient 1. So that would be A11 times X1. All right, that'll give me the nutrient of nutrient 1 in food 1 and the amount that we have. And then, of course, A12, X2 plus ... and then A1N, Xn, and that's the total, whatever the amount of food we bought, that's the total nutrient in the foods that we bought of nutrient 1, okay? And we want to bound that by a lower bound, and we want that to be greater than L1 and less than U1, okay? And we can go down and go all the way down and say Lm, that's nutrient, the final nutrient, and that would be Am1x1 plus Am2x2 plus ... Amnxn is less than Um. And I'm going to simplify that into a matrix form, and I'm just going to say L and A hat, and I define A hat as, in a second I'll show you what I define it as, times X, and that has to be less than U, where L is L1 ... Lm, and U is equal to U1 ... Um. And of course, A hat is just A11, A12, A1N, and then so on, and I rewrite it on the next page. Okay? So that's it, really. Now we just have to clean it up and put it all into one large A and B matrix. The C vector is already finished. We did that initially. All right? So we want to include all the constraints, these nutrient bounds in A, and also the non-negativity of the variables also into A. All right? So let's do that. Let's combine them all. So here, as you can see, I rewrote A hat. All right? So I'm going to say again that I have a variable. I have the constraints so far. I have minus I x is less than 0 vector. And also, I'm going to write A hat x has to be greater than L, and A hat x is less than or equal to U. Okay, so I've just separated those bounds into two different equations. All right, and of course this one has the greater than or equal to, so we want that to be less than or equal to, so it's in the form that we can put it together. So I'm going to say minus A hat x is less than minus L. Finally, putting them all together, I get the large A matrix, which is going to be, depending on how you write it, A hat, and minus I times x is less than, it's going to be, there it is, the U, and the minus L, and the 0 vector that we defined earlier. So here's your B, here's your A, your X is defined, your C was already defined earlier, and this is going to be the most important, this A and B, and I'll show you when you solve it in MATLAB. We'll do it in MATLAB, we'll do it in Excel, and possibly even Python. Okay, so I think I'll end it here, and we'll actually solve the problem in the next few lectures. All right, thanks.